All right, so this is part 3 of 2-6. And we're going to now talk about graphing rational functions that don't follow quite as nice of a pattern. We're going to look at 3 examples of different rational functions that we can graph. And so the first thing that we want to look at when we have some random rational function is we want to look at, is it even or odd? Does it have y-axis symmetry or origin symmetry? So that's something that we looked at earlier in Chapter 1. You may want to go back and reference Chapter 1 to find these. We want to look at the y-intercepts. We can look at our x-intercepts. We can find vertical asymptotes and horizontal asymptotes. These 4 things are going to be key here. Those are the really important steps you want to take. And then what you can do is you can just plot some points. Okay, so those are the strategies that we're going to be using for graphing rational functions. Let's just go ahead and get into it and do some examples here. So I have 2x minus 1 over x minus 1. And you'll notice here that I have this sticky note. I recommend getting these. I think they're great. They are making graphing a lot easier. They sell them at Target and Walmart and make graphing a lot nicer on regular paper. So there we go. You don't have to get them. I just think that they're nice. Anyways, let's go ahead and graph this now. So looking at my function here, I can gather some information. I have a vertical asymptote at at positive 1. And that's because that's what would make my denominator 0. And I can also look for my horizontal asymptotes, which, since the degree of the top and the bottom is the same, my horizontal asymptote is going to be at these coefficients here, so that's y equals 2. And now I don't have a whole lot of other information. So let's go ahead and start with that and draw out our asymptotes here. So at x equals 1, I have a vertical asymptote. At y equals 2, I have a horizontal asymptote. And I can start plugging in some values. Like I said before, you can find your y-intercept and plug in 0. So plugging in 0, I get -1 over -1, and that's just 1. So I have the point 0, 1 here. And I'm going to try plugging in maybe 0.5 and then plugging in maybe -1. So plugging in -1, I end up with, let's see, -1, so -3 on top. And then -1 is -2, so that would be 1.5 or 1.5. And based off of this information and knowing kind of how rational functions work, my guess is that this is going to be something like this. Okay. Now if I plug in 0.5, I can do that. I'm not going to take the time to do that right now, but you can go ahead and plug those points in, and you'll see really quickly that this is what this shape of the graph looks like. But that just tells me this part. I need to see what's going on over here. So let's plug in maybe x equals 2 and x equals 3. And plugging in 2, I get 3 on top and 1 on bottom, so 3. And plugging in 3, I get 5 on top and 2 on bottom, so 5/2, or 2.5. So I have the point 2, 3, and I have the point 3, 2.5. And based off that, you can plug in more points if you want, but I know that this is what my curve is going to look like. So that's our first example. Not too bad. Let's go ahead and look at another example. Now we've got something where we still have the same degree on the top and on the bottom, so finding our horizontal asymptote shouldn't be too bad. Let's see, let me set up our graph here. Okay. So looking at what I have here, I have a horizontal asymptote. Since the degree is the same on the top and bottom, I have a horizontal asymptote of 3/1, or 3. and I have a vertical asymptote. What's going to make my denominator 0? Well, I can factor this 3x squared over x plus 2 and x minus 2. So I have a vertical asymptote, since they don't cancel here, at x equals negative 2 and x equals 2. So let's start with that information. Negative 2 and then a horizontal asymptote at 3. So that's what we have so far. Now, we can go ahead and try to find some points, some intercepts, and so I'm going to make a table of values here. And plugging in, let's say, negative 1, 0, and 1. And then let's say 3 and 4. And negative 3 and negative 4. And that's a good amount of values to plug in. Now, I'm not going to take the time to show you each and every one of these values plugged in because I know that you're able to plug points in here. So I'm just going to tell you what these values are. Plugging in negative 1, I get negative 1. Plugging in 0, I get 0. Plugging in 1, I get negative 1. Plugging in 3, I get 5.4. Plugging in 4, I get 4. Plugging in negative 4, I get 4. Plugging in negative 3, I get 5.4 as well. So again, I did not show my work for plugging those in here, but one, I know those are correct, and two, I know that you guys are able to plug values in. So let's go ahead and graph this really quick. We have 0, negative 1, negative 1. And then at 3 we had 5.4. Okay. And then we had 4. And then on the negative side, same thing. And there's our graph. And you can check your answers on Desmos or on your graphing calculator, but you should be able to do these without any calculator. All right, I'm going to go ahead and flip the page now. We've got one more example here. All right, and notice my degree on the top is not the same as the degree on the bottom, so now we have a different horizontal asymptote. Let's go ahead and set this one up here. And looking at this, I have a horizontal asymptote and a vertical asymptote. Let's see, the degree of the top is bigger than the bottom, so that means no horizontal asymptote, and there's nothing in the denominator that will make my denominator 0. So that's an issue too, so there's no vertical asymptote. So right now it kind of feels like we don't have any information at all. I can try and find some x and y intercepts and plug in some points here. So let's just start there and see what happens. Let's try negative 1, 0, and 1. So plugging in negative 1, negative 1 will give me a 1 on the top and a 2 on the bottom, so 1/2. And positive 1 will give me the same thing. Plugging in 0 will give me 0. So let's plot what we have so far. So that's what we know so far. Let's plug in a few other points. Let's try maybe 2 and 3. And plugging in 2, let's see, plugging in 2, I get 16 on top and 5 on the bottom, so 16 over 5, which is about 3.2. And so that would be 3.2 about there. And we're going to get the same thing on the other side, plugging in negative 2. And plugging in 3, let's see, plugging in 3 we get 81 on the top, and we're going to get 10 on the bottom, so 8.1. So way up here. So we can kind of gather from just plugging in a few points here, it takes kind of the shape of a strange parabola here. Okay. And that's our graph. Now, down below here, we have a little bit more information on different kinds of asymptotes. You may have never heard of a slant asymptote before, but it only occurs in one special situation. Slant asymptotes only occur if the rational function has the degree of the numerator is one more than the degree of the denominator, and then you'll use division to find it. So, looking at this very last example for this section, we have the degree of the top is 2, the degree of the bottom is 1. That's one more up here than down here. So that means we have a slant asymptote. Okay. So they said we're using division to find it. Well, we have x squared plus 1 divided by x minus 1. So that means x equals 1, and we can use synthetic division here. And that coefficient is a 1. There's no x term and a 1. Bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. And 1 plus 1 is 2. That's our remainder. Okay. So we have a slant asymptote. If this is my constant and this is my x term, that's x plus 1 plus 2 over x minus 1. And this part right here is our slant asymptote. Okay, so y equals x plus 1 is our slant asymptote. And that is the end of Chapter 2, Section 6, Part 3.